Greetings everyone. Today's lesson is on quadratic sequences and series. But before we jump straight into that, we looked at other types of sequences and series before. I said that when you are dealing with sequences and series, they can be finite or they can be infinite. And I said that there are three types that we are going to cover: arithmetic, geometric, and quadratic. With the earlier videos, we did arithmetic and geometric, and I specified that from each of these, our job is mostly on how do we identify if a question does not tell you that it's arithmetic. How do you identify that it is arithmetic? Now, I put my sentence on, if it is arithmetic, there has to be a common difference. That sentence, you can also reverse it to say, if there is a common difference, it means it is an arithmetic. If it is an arithmetic, there has to be a common difference. We covered that. Then we also looked at a geometric series, sequences and series. Now, how do we identify a geometric? There has to be a common ratio. If there is a common ratio, it means it is a geometric sequence or series. Then if it is a geometric, there has to be a common ratio. So these words, the changing of the sentences like this, helps us to cover some types of questions, and I've showed you which ones. Now, today, we want to know what to think of when we are given a quadratic series or sequence. Now, moving to quadratic, there are details that we need. This sequence does not have a first common difference. It also does not have a common ratio. It has properties that we need to cover. With arithmetic and geometric, we looked at the nth term. We also looked at how to calculate the sum of n terms. With geometric, we went further to look at the sum to infinity and as well the convergence of a series. But with quadratic, we are going to look at finding the nth term. We need to look at the formula on how to find the nth term. Now, the word quadratic, yes, we are dealing with sequences and series. However, this word, we have seen it in algebra, and the thought of how to handle quadratic equations must not be dismissed because we are on sequences and series. It is the same thing. The quadratic, if we look at the nature here, an squared plus bn plus c, it is the exact quadratic standard form of a quadratic that we know. Now, there are a few things that one should know from this. Now, Tn given by an squared plus bn plus c. If you are asked to determine the nth term, your job is to find the value of a, the value of b, and the value of c. Now, there are a few equations that can help you to do that. 2a is equals to the second difference, which we shall see with an example soon enough. Then 3a plus b is equals to t2 minus t1. We shall see where all of this is coming from. Now, we have a plus b plus c is equals to t1. So, if you manage to master these three together with this general form, then you shall be able to answer most of the exam questions based on what is coming. Now, without further wasting time, let's go and look at where all of this was coming from, and we look at an exam type question as well. So with me here, there is this question here, which we shall use to actually understand what I was referring to earlier when I was talking about T2 and T1. The question is saying, given the following quadratic number pattern, 5 minus 4 minus 19 minus 40, we have these questions to answer. Number 1, determine the second difference of the sequence, 2 marks. Number 2, determine the nth term, Tn, of the number pattern. Number 3, which term of the pattern will be equal to minus 25,939. So these are the questions we want to attempt to solve. But now, to answer these ones, to answer such questions, one has to come or to create something shown here. Let's write this as the solution. Now, I am given the numbers here. The pattern has 5. The pattern has the number 5. It is minus 4. It is minus 19. It is minus 40. Now the first one here is what I label T1, followed by T2, followed by T3, followed by T4. So I will write down those equations that I wrote earlier, that we saw earlier before this example. We said that 2a will be equals to D2. We said that 3a plus b will be equals to T2 minus T1. I also said that a plus b plus c will be equals to T1. So now this T2, T1 that we are looking at, and even D2, they are coming from this labeling which I have given at the top here. Now, first difference in maths means subtraction. So we are going to be saying the term minus the preceding term. That's how we get this. For example, minus 4 minus 5, you will get minus 9. That's how I got this number. Then minus 19 minus 4, the use of a calculator can also help here. You will get minus 15. If you say minus 40 minus 19, you will get minus 21. Now, I have done, this is my first difference. Remember, the question we are trying to answer is looking for the second difference. So this here is the first difference. Now, to get the second difference, I also have to find the difference between these consecutive terms here. Now, if you do minus 15 minus 9, you will get negative 6. If you say minus 21 minus 15, you will get minus 6. Now, as it is clear here, the second difference of a quadratic number pattern, not just this one, but any number pattern that is quadratic, will always be common. Like I say, there is a common answer after this difference, which means there is a common difference here. Now, since this is a common difference, it means that this pattern here, which we said the first difference, is actually an arithmetic series. Since there is a common difference, it's arithmetic. So the first difference of any quadratic number pattern will be an arithmetic series, since it will have a common difference. Now, we shall see another question that will actually use this. So here, we have answered our question. We have found that the second difference, D2, is equals to negative 6. We have answered question number 1. Question number 1 said that determine the second difference of the sequence. So I have done that and found my answer to be 2. Now we want to try and find question number 2, the solution. Determine the nth term Tn of the pattern which we are dealing with. This is the pattern we are dealing with. So we want to find Tn. Now here we need to remember the nth term formula. We learned that Tn is given by an squared plus bn plus c. This is the nth term formula for quadratic. Now our job is to just find the value of a, the value of b, and the value of c. Now following what I gave earlier, or this which is on my right hand side here, this formula here, we said that 2a is equals to d2. So what you can do is to say, alright, this is my d2. There are these numbers we have to learn to circle. I have this one. It is representing d1. I have this one representing I have this one representing t1. I have this one representing t2 minus t1. I also have this negative 6 here representing my d2. So from what we just learned from here, from this formula we have here, I can safely say that 2a, sorry about this, is equals to this, which is my d2. Then here, I can also say that 3a plus b will be equals to t2 minus t1, which is in this case negative 9. I am following this formula, but I am now using this sketch which I did here to show that. Now, I also have this one which says a plus b plus c is equals to t1. It means that my a plus b plus c will be equals to 5. Now if I have these here, remember what we are trying to find is the value of a, the value of b, and the value of c. So where do we go from here? I can now start from this bottom one here. We said that it gives me 2a is equals to negative 6, coming from 2a is equals to d2, since my d2 is equals to 6. Now I can solve this algebra by dividing both sides by 2. So my a will be equals to negative 3. I have already found the a. This part is done. Then I need to find b. Now going up, I am solving this problem from bottom here going up like that. So I have found a from this. Now there is this second equation here. 3a plus b is equals to 3a plus b. It says that it is equals to t2 minus t1, which now means that 3, wherever there is a, I got my value of a here. My value of a is negative 3. Then plus b is equals to, if you look at this, my t2 minus t1, it is this number here. T2 minus t1 gave me minus 9. So this is equals to negative 9. This creates 3 times 3, that's negative 9, plus b is equals to minus 9. I have formed an equation which only have b as the unknown. In the end, I have minus 9 plus this one, it crosses, it becomes positive 9. So my b is equals to 0, which means this part is also done. Now I am left with finding c. So how do I find c here? If I am asked to find c, we are now also on this stage here, which means that a plus b plus c is equals to t1. So where there is a, I put minus 3. Where there is b, I have my 0. Then I have my c. Then my t1 in this case is 5. Again, I have c is equals to 5. Then this 3 crosses the equal sign. It becomes plus 3. So my answer will be equals to 8. I also have found this one. Therefore, in the end, one can say Tn is equals to minus 3, then n squared, then plus 0, then plus 8. This here is the answer we were looking for. That's how we can use this diagram here. And the combination of the formulae I gave earlier, that's how they get to be connected, and then it gets to simplify our work here. So I used the formula 2a is equals to d2. I've used the formula 3a plus b is equals to t2 minus t1. I've also used the formula a plus b plus c is equals to t1. But all of that just being helped by what we have in this, which I sketched here. So now, there is a next question. The question says that, which term of the number pattern will be equals to minus 25,939? So here, remember, the topic we are dealing with says quadratic sequences and series, which means we are dealing with quadratic. Now, when they give you a question like this, which term of the pattern, we want to locate a position here. We want to find the n, which means that my solution for the first question is what I'm going to use. So we are given that at point, we want to find it minus 25,939. So here, I will substitute wherever there is Tn. This is what I'll put. So it means minus 25,939 is equals to minus 3n squared, then plus 8. I want to find the n here. So this one can cross to be positive 3n squared is equals to 8. And this one can cross to this side to become plus 25,939. Now 3n squared will be equals to, then we can go to our calculator. So if we punch our calculator, we will get that this value will be 25,000, sorry about that, 25,947. 25,947. Now I want to find n, so I have to divide both sides by 3. If you do that, you will end up getting n squared is equals to, again you punch this in a calculator, to give you 8,649. Now therefore, for me to get n here, I have to take the square root of 8,649. I am not putting plus or minus here because n is a position and also at times is referred to as the number of terms. So at this point, I need a positive answer only. And if you punch a calculator, you will get your n equals to 93. So the position is 93 and the position cannot be negative. So at this point, we have answered this question. Now I want to bring another question from a different view, which tests another type, and then at the same time we apply the knowledge that we just learned. So this other question says that, and it's an exam type question, given the quadratic number pattern -3, 6, 27 and 60, and with the 3 dots indicating that it is infinite, determine the general term of the pattern in the form Tn is equals to an squared plus bn plus c. So we are to just exactly apply the concept that we learned. This is how we are supposed to see maths. The questions won't be the same, but the idea tested will be the same. So I will have my T1. Okay, I have -3, I have 6 here, and I have 27, and I have 60 this side. So I have my T1, my T2, my T3, and my T4 from what we just learned. Now here, if I have these ones, if these are what I'm given, then we looked at how to calculate the first difference. If you say 6 minus -3, at this point it will give you 9. If you say 27 minus 6, you will get 21. If you say 60 minus 27, you will get 33. Now we go for the second difference. This is first difference, so we go for the second difference. If you say 21 minus 9, you will get 12. If you say 33 minus 21, you will get 12. So this one here, right here, this one is your second difference. This one here is the first difference. But we discussed something about this. This which we are referring to as the first difference is actually arithmetic. It's something to remember. We shall need that. Now, following what we need here, we want to find this formula. We said that our job is to find a, b, and c in this equation. an squared plus bn plus c. So I want a, b, and c. Now, from the notes we said 2a is equals to d2. Then I said that 3a plus b will be equals to, okay, let me circle these numbers. It's just as I did in the example we looked at. I said we will need the value of t1, which is here. I will also need the value of t2 minus t1. I will also need the value d2. So 2a is equals to d2. 3a plus b is equals to t2 minus t1. That's how I got this. Then I also have to say at this point, a plus b plus c is equals to -3. Therefore, from this, 2a is equals to 12. I can divide both sides by 2, which means my a will be equals to 6. So a here is done. I have found 6. Then I come to this stage, just like we did, from bottom going up. It means that I have 3 multiplied by a, then plus b being equals to 9. It means wherever there is a, I can now put 6. 3 plus 6, 3 by 6, then plus b is equals to 9, which means that b is equals to 9 minus 18. If you multiply here, you get 18. Then it crosses, it becomes negative. Then my answer for b is 9. So here I have found my b to be negative 9 at this point. Now we move further to this upper one here. A plus b plus c is equals to 9. We say that a plus b plus c is equals to 9, which means that wherever there is a, I am putting 6. 6 minus 9 plus, sorry about this, I circled the wrong one, I picked the wrong one here. I need to erase this a bit. this one here. All right, now a plus b plus c is supposed to be equals to a plus b plus c is supposed to be equals to minus 3, not 9. I had picked a wrong one there. So it is supposed to be equals to negative 3. So plus c here will be equals to minus 3. Now here you get minus 3, 6 minus 9. Then plus c is equals to minus 3. In the end, c is equals to minus 3 plus 3, which is equals to 0. So I have found my c as 0. Therefore, my Tn here is equals to 6n squared minus 9n plus 0. So I have answered that question and I get 4 marks for that. So this is how we were supposed to attempt this question, exactly following the steps I gave. Then there is this question number 2. On question number 2, question number 2 says that determine the value of the 50th term, the value of the 50th term, which means my n is equals to 50 in this case. Therefore, I am looking for T50 equals to wherever there is n, I put 50, then I square here, minus 9, I also put 50 here. If you punch these numbers, here, you will get 14,000. You will get 14,550, 14,550. So this becomes the answer for this question here. Now, there is question number 3. Question number 3 requires us to pay attention. Show that the sum of the first differences of this pattern can be given by. The word sum is mentioned here, but in my notes, I did not give any formula to calculate the sum of terms of a quadratic series or sequence. Now, there is this part which says first difference. I mentioned earlier that this, which we call first difference, is actually arithmetic sequence because there is a common difference. So this question we can change it to say, show that the sum of first n terms of an arithmetic sequence given as 9, 21 and 33 is given by Sn is equals to 6n squared plus 3n. So we know how to calculate the sum of n terms of an arithmetic. I am now dealing with 9, 21 and 33. This is now my sequence. And my a here is 9. My div is equals to 12. So the sum of n terms is given by n over 2, 2a plus n minus 1, then d outside. I can use square brackets here. Now my job here is to substitute now a and d. Now this is equals to n over 2. Wherever there is a, I'm going to put 9, then plus. My n remains, my 1 remains, my d is 12. If we simplify further, we have n over 2, 18 here, plus I multiply everything by 12, so I'll get 12n minus 12. In the end, it simplifies to n over 2. Then here I write 12n, then 18 minus 12, my answer is positive 6. Now, I can multiply everything inside by n over 2, which means I will get 12n squared, then O over 2 plus 6n, then over 2. Now from here, I can simplify further to say this is equals to 6n squared plus 3n. Now here, Sn is equals to. So the question was show that, so we have managed to show that it reduces to 6n squared plus 3n. When a question says show that, it means what you are given here is your solution. Now, you are to start somewhere else and reduce up until you reach that given solution. So this was exactly what this question required. But we paid attention to this sentence here to say the sum of the first n first differences which we regarded now to say they form an arithmetic series or sequence based on the existence of a common difference. So at this point, we have answered these types of questions. Your job is to find other type of or past exam paper questions, look into how they test, but our idea in answering quadratic starts from having a structure like this and bearing in mind that this part, the first difference is always arithmetic. Then we have formulae 2a is equals to d2, 3a plus b is equals to t2 minus t1. We also have a plus b plus c is equals to minus 3. A combination of that can help you generate the nth term formula, Tn. So we used all of that, and it is important to pay attention to the language. Please subscribe on YouTube, continue to revise and ask questions where necessary. I thank you.